Hi guys, welcome back to the channel. So today we are going to be solving find the sum of power of all subsequences. So we are given an array of nums of length n, and then we are also given positive integer k, and then the power of an array of integers is defined as number of subsequences with their sum equal to 0, and then we need to return the sum of power of all subsequences of the nums. And then it can be large. We need to make sure that it should be modulo of 10 power 9 plus 7. So we are given an array, and then subsequences means, suppose let's say I have this particular array, and then now when I say subsequence, it can be any elements which are present in the array. Suppose I can take 1, and then I can take 3, and then I can take 2. So this will be one of the possibility. And then let's say if I want to choose differently, so I can take 2, I can take 3, and then I can take 4. So this is one more possibility. So suppose let's say for each case, so how many number of subsequences are there for the particular array. So for this particular case, I can choose either I can take or I cannot take. So for this it is same as this. So for each case it is going to be either two cases. So for this it is going to be 2 power n. That means for each index we have a possibility that we can take into the subsequence or we cannot take into the subsequence. So these are the number of subsequences we can make out of the array. And then what is one more thing they are saying, so we need to sum the power of all subsequences of the nums. So these are the different number of subsequences. Now out of all these subsequences, let us pick that we have one, and then 2. So let us take this as our subsequence. Now we need to find the number of subsequences with the sum equal to k. That means let us assume that we have a k equal to 3. Now when we want to pick the subsequences out of this subsequence, we need to pick in such a way that the sum becomes 3. That means we can pick this one, and then we can pick this one, so that the sum becomes 3. And then one more case is we can pick 1, and then we can pick 2, then the sum becomes 3. That means we have two subsequences in this particular subsequence, so the power of this subsequence becomes 2, and then we'll add it into the answer. So to calculate this type of things, it is going to take the 2 power n subsequences. Out of this we need to find the subsequence whether it is possible or not. For this it will take a lot of time, so we'll try to reduce the time and space complexity for this. Suppose let's say instead of thinking different this much, can we do it in a better way? Suppose let's say we have a subsequence. We have a subsequence where I have 1 and then 2. Now instead of finding the subsequences which have the subsequence of like sum equal to 3, can we do it in a reverse way? So we have 1 and then 2 with the sum equal to 3. Now we need to figure out the number of subsequences it can be part of, this particular subsequence can be part of. Suppose let's say 1 2 should be part of the particular subsequence. That means this should be present. So for this there will not be any possibility of 2 whether we can take or not take. We must consider this particular case, and then for this case we must consider this particular case. Now when we take other elements which is going to be 1 2 and then 3 and then 4, we have a possibility that we can either take this particular 4, or for this 3 we have the possibility to take this, and then for this we have the possibility to take this, and then for 1 we have the possibility to take this. So whenever we have a subsequence with the sum equal to k, that means we must take all the elements which are present in this particular subsequence, and then whatever the length which is present out of this, we should remove this length, and then that becomes the number of subsequences this particular subsequence will be part of. So this is going to be 2 power total n minus length of subsequence. So this will be our number of subsequence this particular subsequence will be part of. So this will be part of these many subsequences, this particular subsequence. So we need to find all the subsequences with the particular sum, and then after getting the particular sum, we'll calculate this particular answer, and then we are going to add it into the answer. Now after now we need to find all the subsequences with the sum equal to k, and then we need to make sure, suppose let's say I have one, again I have one more. So for this, if I consider 1 and then 1 and then 1, this has length of 3, but whereas 1 and 2 has a length of 2. That means this will take 2 power n minus 3. These are the number of subsequences it will be part of. So for this case it will be n minus 2. That means if the length changes, if the subsequence length changes, that means it is also dependent upon the subsequence. Now we need to find the number of subsequences with this particular sum, and then it should end at some particular point, and it should have some particular length. That means we are going to consider one case where we have all these things, which is going to be like, let us take the same thing. So 1 comma 2 comma 3 and then 1 and then 2. So let us take this particular solution. So now when we want to pick the each element, then we are going to consider dp of index, and then we are also going to consider the sum, and then we are also going to consider length. So this dp will give us the number of the actual answer, which is going to have this particular index, and then have this particular sum, and then have this particular length, and then out of this we are going to return the answer. So this dp will give us the answer. So let us see the solution. And then one more thing is, suppose we want to take the 2 power, we want to calculate the 2 power n value. That means we need to consider it in a better way. Suppose let's say we want to find it for 10 power some 10 power 6. That means we need to find it very faster. So whenever we want to find it very faster, suppose let's think we have 2 power n. That means we can write it as 2 power n by 2 and then whole power square. So whenever we want to calculate 2 power n, we'll try to calculate 2 power n by 2, and then we are going to do the square of this particular thing. So we'll try to reduce this particular 2 till we find it as 1 or n becomes 0. N becomes 0. And then let's say if the n is odd, that means we can reduce it as 2 power n minus 1, and then we are going to multiply it with 2. So this is going to be our solution. Suppose if it is even, then we are going to break like this. If it is odd, we are going to break like this, and then at last we are going to return the answer. So let us see the solution for this. So we are going to take the dp, which will consist of dp of 101 and then 101 and then 101. So this will be our constraints where we have the length can be maximum 100 and then k can be 100, and then some also sum is should be less than or equal to 100. So we are going to consider that. Suppose let's say the sum equal to 0. That means we have found the subsequence which will have this particular sum where it will be k reduced, so sum becomes 0. That means with this particular length and this with this particular index and then with this particular sum it is going to become 0. Now let us take the power where we'll have x power y. We need to calculate x power y with the modulo of mod. Now when we say y equal to 0, that means the power becomes 0. That means we need to give it as 1. Now when we want to move to the next time, we need to check, we'll reduce the power to y by 2 such that we'll get some power uh, which is going to give us a total value for this answer, and then we are going to multiply it double. Why? Because as we have already seen, when we have 2 power n, we are going to reduce it as 2 power n by 2 and then square this particular answer. So by this recursive solution, we are going to get this answer with the p, and then we are going to multiply it double. Suppose let's say we have uh, 2 power 5. 2 power 5. Now I got only for 2 square, which is answer, and then I am going to, this will be p, and then this is going to be 2 square. But there is one more 2 we need to multiply. That will happen when we have y will be odd. That means we are going to consider one more case where we have y y percentage 2 will have some remainder. So at that particular case we are going to multiply p with the 2, and then we are going to do the modulus operation so that it will not exceed 10 power 9 plus 7. So if it is a even, then we are going to consider the same thing, which is p. Now when it becomes sum equal to 0, then we can say that this will be the answer where we have x power y, which is going to be nums dot size, and then we are going to reduce the length of the subsequence. Suppose let's say if it comes out of the indexes, or if the sum becomes less, that means the subsequent sum is greater than k. So we should not consider this particular case. So that's why we are going to return it as 0. Suppose let's say the sub problem is already solved. That means this particular index with this particular sum and then with this particular length, it is already solved. That means we do not need to calculate the again the same thing. So we are going to return the particular answer which we got with the dp. Now let's say we want this particular sum, and then we have nums which is less than this particular sum. That means we can reduce the sum such that the sum will remain in within constraints which is less than or equal to sum. So here we don't need to consider this particular sum. Why? Because we are already checking here. So but anyhow I kept the condition. So suppose sum is greater than or equal to nums of I, then we have two choices. Either we can pick this particular nums I, or we cannot pick this particular nums I. So let us see if we pick if we don't pick this particular nums I, that means we are going to get back to the previous solution, and then we are going to come with the same sum and then with the same length. Now let's say I want to pick this particular number. That means I'll reduce the sum, and then I'll go back to the previous index, and then I am going to add the length. Why? Because we are increasing the length of the subsequence by adding this particular num. That's why we are adding the length. Now let's say if nums of I is greater than sum, that means we cannot pick this particular nums I. Why? Because if we pick this particular nums I, then the sum becomes less than 0. that is not a valid case. So we are going to say I becomes -1 and then with the same sum and then with the same length, and then at last we are going to return the answer. Yeah, that's all for this video. Thanks for watching.